start going over section 4.1. So section 4.1 is about applications of the first order derivatives. And the applications are going to be to what's called how to find where the function is increasing, where the function is decreasing, and also later to find maximums and minimums. So this is actually one of the most important, if not the most important, problem in calculus and in general in everything else. So to find maximum or minimum some quantity, so for instance, you're talking about a company, you want to figure out when is the when are you going to maximize the profits, right? When you're talking about business, the whole point of business is to make as much profit as possible. So if you know what the function of your profit function, how can you find? Hello? Yeah, so how can you figure out where the maximum is? Okay, so today maybe we'll start looking first where the functions are increasing or decreasing. So let's start with the definition, okay? So a function, so a function f is increasing in an interval, let me just say in interval AB, if you have this, you have that f x1 is less than or equal to, or let's just say less than fx2 if x1 is less than x2, and those are both points inside the interval. So x1, x2 are inside the interval AB. Okay, so what does that mean? So what's the important point in this definition is that f is increasing in this interval here. Okay, that means that fx is less than fx2 if x1 is less than x2. So let me draw the graph so that makes a little bit more sense. So here we have some function, maybe like this, and let's pick any interval here. Let's say this is a and b. So this is my a and this is my b. And so I'm going to pick 2 points, x1 and x2. So this is my x1, this is my x2. So what can I say? So x1 is of course less than x2, right, in this picture. And then I have these 2 points here on the graph. And what's fx1? fx1 is this much here, right? That's fx1. And this is fx2. So this one here is smaller than this one. So that's saying that the function is becoming kind of, if you think of x as time passes, the function is becoming bigger and bigger. So fx1 is less than fx2 if x1 is less than x2. For a later time, the function is bigger. So that's we're saying that f is increasing, right? So f is increasing. Okay, so this is the graph y equals fx. Okay, so that's an example of something that's increasing. I can get something that's decreasing, which, well, that basically looks like this. So you have again x and y. This is my x, this is my y, right? So my graph, maybe it looks like this, right? So then if I again pick points, so this is my A, this is my B, and so in that interval, I pick any 2 points, let's say x1 and x2, right? If I have that at a later point, my function is smaller, then I have that the function is decreasing, right? So that's an example of something that f is decreasing. Okay, so let me not write that down again. So instead of, so if I did that, maybe I should write it down. So f is decreasing in this interval AB if we have the opposite inequality. We have that fx1 is greater than fx2 if x1 is smaller than x2. So for a later time, so that's the x2, that's later, the function is smaller. So that's saying that the function is going down in time or in x, right? And this has to be true for all x1s and x2s inside this interval here. So, and x1 and x2 belong to this interval AB, right? See, it doesn't matter which x1 and x2 I picked, right? As long as x2 happens later or is bigger than x1, then the function at the later point is smaller. So that would be an example of decreasing, okay? So that's the meaning of increasing and decreasing when you want to write it in terms of formulas. Now, the question is what do the derivatives have to do with that? Well, the derivatives are very important because let's look at this picture. Okay, so let's look at this picture here. Let me erase some of these things here. So I have here an example of something that's increasing. So let's pick a point here, any point. Let's take some point here. So let's pick this point here and let's look at the derivative at that point, right? So let's look at what's the meaning of the derivative. You remember the derivative is the slope of the tangent line. So let's look at the tangent line. So the tangent line looks maybe like this, right? So that's my tangent line. And now what can I say about the tangent? Hello? Yeah, so what can I say about the tangent line at that point? Well, you're looking at it, it looks like the slope of the tangent line is bigger than 0, is positive. So, and it turns out it's equivalent to saying that it's increasing. So the function is increasing when the slope of the tangent line is positive, or that's the same thing as saying that the derivative is positive. So this is, let me just write it here. So so if f is increasing in an interval AB, then the derivative of f at any point in that interval is positive for any x in that interval. Okay, so to say that f is increasing is the same thing as saying that the derivative is positive. Okay, see, that's a very nice thing. So so that a very easy way to check something is whether it's increasing or not. Looking at the formula of the function, it's really hard to find it out, but if you now know the derivative, for the derivative it's much easier to find out when the derivative is positive or negative. Similarly, we can look at the like this decreasing example. Again, if I take the slope at any point is decreasing, that means the slope of the tangent line is negative, so that means the derivative is negative. So I'm going to write it again here. F is now decreasing in this interval again, that's the same thing as saying that f prime of x is now negative. Okay, again for any x in this interval AB. Okay, so the important thing here is again f is decreasing is equivalent to saying that the derivative is negative. So positive derivative is the same as saying f is increasing. Negative derivative is the same thing as f is decreasing. Okay, so let's take one example. Here is an example. So let's take fx to be x squared, right? So that's my example, fx equals x squared. I want to figure out where the function is increasing or decreasing. So what do I have to do? Let's take the derivative. So that's what this thing said in the beginning. So let's look at the derivative. So the derivative of x squared is 2x, right? Well, when is this increasing? When is this increasing? Well, when is f increasing? F is increasing whenever the derivative is positive. So so let's say f is increasing. That's the same thing as saying the derivative is positive. Okay? Well, where is it positive? What is the derivative? Well, that's my derivative, 2 times x. 2 times x is positive whenever x is positive. So that's the same thing as saying that x is positive, right? Because f prime x is 2x. If a number is positive, you multiply by 2, it's still positive, right? And the same thing, f is decreasing. So that's the same thing as 2x is negative. Well, that's the same thing as x is negative. Okay? So what that means is, well, f is increasing. So what I have here is that f is increasing when x is positive, and f is decreasing when x is negative. Okay, so what does that mean? That means my graph of my function, whatever it is, it looks like this. For positive numbers of x, well, what are the positive x's? They are the ones which are on the positive side, right? So for those things, the function is increasing. So it kind of looks like this, right? And for the negative ones, it's decreasing. Where are the negative ones? Negative ones are here. For these things, the function is decreasing, so it looks like this, right? Well, does this look like the function of fx equals x squared? It exactly does, because the function fx equals x squared, the graph of that function is the parabola, which kind of looks like this. Okay? So we're gonna do now a little bit more complicated examples, right? So if you do you guys have any questions? Okay, so if
Yeah.
yes,
Can you re-explain that, just the graph part? Like, where is f increasing, where is f decreasing?
right. So the function is increasing in here, right? So it's going up, and we found that the derivative is also positive in that part here, because the derivative is 2x. 2x is positive whenever x is positive. And it's decreasing here for negative values of x. So this part here, the x here is negative. So, and that's the same place where the derivative is negative. Okay. So again, derivative positive, the function is increasing. Derivative negative, the function is decreasing. Okay. So let's do a similar example here. Here is the problem. You're given the graph of a function. Determine the intervals where f is increasing, constant, or decreasing. So I'm going to look at this function. Let's look at this function. Where is this function increasing or decreasing? Well, this function is increasing. Let's look. Well, where is it increasing? It's increasing here, right? Here, all the way, it's increasing. And here, this part here, it's also increasing, right? So, well, when they ask you where, it means for which values of x. Okay, so that means I should be looking at the values of x for which it is increasing. So it's from negative infinity to negative 1, and then from 1 to positive infinity. So that's what I wrote. F is increasing in negative infinity to negative 1, and in 1 to infinity. So if we write this using this notation we had before, we should write negative infinity instead of and in. We should really write here union. Okay, so we don't really need to write this part here and in. So we would write this negative infinity minus 1 union 1 through infinity. Okay, so I'm just going to write it like that. Okay, and where is the function now decreasing? Well, it is decreasing in this interval here, right? So that means here, between negative 1 and 1. And that's what we have. F is decreasing in negative 1, 1. And there are no intervals where f is constant. So that's our problem 1. Okay, so let's do problem 2 here now. Let's do, so we have to find intervals where this function is increasing and the intervals where it is decreasing. So what are the things that we have to do? Actually, let me erase this and do it, or actually, well, that's okay. So
can you erase all of that like and do it like so we can like physically see how?
yeah, I'm gonna do it like this.
Looking good.
So the function is x to power.
For problem 1.
What?
I had a question for the previous problem.
Okay.
How do you know that there are no constants? Like, what do you have to look for?
Well, I mean, it would mean that the function, there is a place where the function is flat. There is no place like that on this graph.
Okay.
Okay. Okay. So this is the function. Let me just copy it. And okay, so I want to find where this function is increasing, decreasing, or something like that. Well, look, it's a complicated function. How do I know where it's increasing or decreasing? So what do? We find the derivative. So let's find the derivative here. So the derivative is, let's find the derivative. That's going to be what? 4 times x to power 3 minus 4 times 3x squared plus 0, correct? So then let's simplify. Why do we need to simplify? Because we need to find where the function is going to be 0. Okay, so let's write this as, so what can we factor out here? What we can factor out is 4, because there is a 4 here as well. And also we can factor out x squared because there is x to power 3 here, and that has 2 x's there. Okay, so let's factor these things out. So I have 4, then I have x squared. So then what do I have left from the first term? From the first term, I have just x, right? And from the second term, well, I factored 4. I factored out x squared. So the only thing that remains is the 3. So I have to write minus 3. Okay? So that's my derivative. Okay. Now I need to find where this derivative is positive and where it is negative. So let's actually do it like this. So g prime x again is equal to 4 times x to power 3 times, x to power 2 times x minus 3. Okay? So where is this expression positive or negative? For which values of x? Well, one thing I know is that x squared is always positive, right? So, well, so x squared is always non-negative. So that means what? That means here I have a number that doesn't change the sign. Here I have an x squared, which is always non-negative. So the sign really only depends on x minus 3. So this thing here is positive. So g prime x is positive if is, let's say, non-negative if x minus 3 is non-negative, and g prime x is less than or equal to 0 if x minus 3 is less than or equal to 0. Correct? Yeah? Because why is that again? Because this, the rest, this
so
part here.
on the test, will we have to write it out like that?
On what?
Or like say on the test, will we have to write it out like that?
Yeah, in this kind of example, you can do that. Yeah, but in the other examples, we'll have to do a little more work.
All right.
Right. So, so in this case here, I'm gonna tell you in another example a little bit more systematic way. So in this case, we have x minus 3 is greater than or equal to 0, but that's the same thing as saying what? X is greater than or equal to 3. How do I get that? I just move 3 from here to there, okay? And similarly here, I have x is less than or equal to 3. So that means the derivative here is positive whenever x is greater than 3, and it's negative whenever x is less than 3. So that means my function, well, what is the meaning of derivative greater than 0? That means it's increasing. So this is the same thing as saying g is increasing, and this is that g is decreasing. Okay, so g is increasing when x is greater than or equal to 3, and is decreasing when it's less than or equal to 3. So I think in the problem they ask you to write the answers using interval notation. So we don't have them in interval notation here. So how do I do it into interval notation? Well, we just say that x is greater than 3, greater than or equal to 3. You don't have to include the equality. You just forget about the equality. Just write x greater than 3. That's the same thing as saying that x inside 3 to infinity. And x is less than 3. That's the same thing as saying x is in negative infinity to 3. Okay?
What about the 4x?
What?
4x squared.
4x squared, yeah, because x squared, 4x squared is positive, that's not going to affect the sign, right?
Okay.
So that means g is increasing whenever x is in this, sorry.
Can you say that notation again? Sorry.
Which part?
The last thing you just wrote. The last two things you just wrote.
These ones?
Yeah.
Yeah, so saying that x is greater than 3 is just a different way of writing this, because if you look on the line, this is say 3, saying x is greater than 3 it means that x is in here. So that means the interval from 3 to infinity. Right? So you go here, you go all the way there. And x less than 3, it means x is here, or you can write it as negative infinity to 3.
Quick question.
Yeah.
What is that symbol in between x and 3?
Oh, that means belongs. So this thing here is just the same thing as saying in.
In? Okay. Thank you.
Yeah.
I thought the inequality was or equals, no?
Yeah, the equality is not really important because
That 3 is not, but then you're saying that 3 is not included, right? In the
yeah, so 3 is not included because when you're talking about something increasing or decreasing, it doesn't make sense to talk about saying that
right?
you're increasing at a point, really. So you want an open interval.
So it's always going to be pretty much open, right?
Yeah. So if you make it closed, I'm not going to deduct any points. But I mean, it doesn't make a difference, really.
Right. Because that's where you're starting to increase or decrease.
Yeah, exactly. Okay, guys. So if there is no questions about this problem, yes?
So the highlighted part, is that the answer in interval notation?
Right. So this one here, so the function is increasing when x is in here, right? And it's decreasing when it's here.
Okay.
That's the answer. Okay.
Thank you.
Okay, so let's do another one.
Can I see the problem so I can take a picture of it?
What?
Can I see the problem again so I can take a picture of it? Like, so
You don't need to take a picture. I'm going to send this to you.
Okay.
Here is the problem. Find the intervals where the function is increasing and the intervals where it is decreasing.
All right.
Okay, so we found it. See, my solution is a little bit different here. So here I have a different solution. Hopefully I'll be able to tell you a little bit about it next. It's a little longer, so, well, yeah. So let's see this one here. This one here, let me actually not go through all the details, just explain what's written here. So what we have again, find the intervals where the function is increasing or decreasing. So this is my function. So again, what I have to do, I have to take the derivative. So the derivative of this, actually let me do it again. So I have to find where this function here, ht equals t divided by t minus 1 is increasing, decreasing, etc. Etc. Right? So again, what we have to do, we have to take the derivative. So h prime of t is equal to t divided by t minus 1 prime. So if I do the derivative, I have to take the quotient rule in this case. So it's going to be the t prime times t minus 1 minus t times t minus 1 prime divided by t minus 1 squared. So after I do some simplifications, well, first of all, t prime is 1, so this is equal to 1. So I can write 1 times t minus 1, that's just t minus 1, minus t, and this is also 1, right? T minus 1 prime is 1. So I also have to write just t, divided by t minus 1 squared. So then I can just cancel this and that. So I get this is equal to negative 1 divided by t minus 1 squared. So that's my derivative, okay? So what does that mean? What can I say about the sign of this? Is this positive, negative, anything like that? So, well, it is, well, let me actually write it again. I have that h prime t is equal to negative 1 over t minus 1 squared. Okay? Well, what can I say about the denominator? The denominator is t minus 1 squared. What is the sign? It's always non-negative, right? Okay, no matter what I do, except for t equals 1, if I t equals 1, it is actually equal to 0. But I don't care about that particular point. Well, I mean, as I said, 1 point doesn't really matter. So t everywhere where the function, the derivative makes sense, it is positive. Okay, the derivative is positive, but then I have what? I have this negative sign, right? So that means if I have negative sign times something that's positive, then the answer has to be less than or equal to 0, correct? Yeah, I have negative times some number which is positive. So the whole thing is non-negative, so that means the function is increasing always. So h so h is increasing. H is increasing everywhere in its domain. In the domain. Okay. So what's the domain here? The domain is the place where the function makes sense, and it makes sense everywhere except t equals 1. So what means everywhere in the internal notation? It means for all x's, right? So in reality, we can write that h is increasing in negative infinity to 1 and 1 through infinity. And the reason I did it like this is because 1 is not in the domain. Or you can write just negative infinity through infinity too.
Wait, I have a
That
question.
would be fine too.
I have a question.
Yes?
Wait, why is it increasing if it's less than 0, isn't it?
Oh, you're completely right. Sorry, I got distracted.
Oh, wow.
Yeah, so it's decreasing. You're completely right. So decreasing. Sorry, just a second.
Good point out there, Mo.
Good looks, bro. I'm just looking out for the class. That's hilarious.
Okay, guys. So is this clear?
I have a question.
Yeah.
So so h is decreasing because of the negative sign
Yes.
in the function?
Not in the function, in the derivative.
Oh, okay. I mean, yeah, the derivative, yeah.
Right. Because the rest is positive.
So which part is negative then?
The negative sign is like -1 times a negative
Oh,
number.
you're saying the negative has a 1 inside. I see what you're saying. Oh.
Right.
But why those? Isn't that one term though, technically?
Sorry. Sorry, what?
Isn't that one term though?
Yeah, I mean, you can write it as -1. Sorry.
That's so funny.
Sorry. So it's going to be -1 times 1 over t minus 1 squared. You can just write it like this, okay?
Okay.
So it's going to be the negative number times 1 over t minus 1 squared.
So the 1 over t minus 1 squared is going to be positive, right?
Right.
Of the squared.
Yes.
Any number in t is going to always be positive.
Right.
Okay. Wow, this is difficult.
Okay. Okay, so let's do one more. Actually, let me see if the other problem. Actually, let's do this other problem here. So I'm gonna do up to problem 5 because
Wait, I got one question.
yes.
Could you go back to the answer for a second? I thought you said we have to like write X with an E and the E notation thing to write the answer.
The interval notation?
Yeah.
Yeah, that's the interval notation here.
Where?
This one.
No. Oh, that's interval notation? I
Right.
thought you needed to write like the E. Why did you write that E thing last time?
Oh, you mean you can do it, you don't have to do this E thing. Yeah, you just have in the problems they say, so you can write it's increasing in this thing. So that's how I wrote. CH is increasing in.
But I think it's -1, no?
Oh, okay.
No, it's
All right, thank
positive one.
Why?
Because you have, if you plug t equals 1, this becomes 0. If you plug t equals -1, you get -2.
What?
So those are the things that, so where is the function not defined? It's not defined at 1, right? If you plug 1, it's
Yeah.
not defined.
Oh, where it's not defined, that's what we have to do first?
Yes.
Oh.
Okay. Can you repeat that? Okay. So let me do one more problem, because in the other class I also did up to problem 5, so we didn't do everything. So I'm gonna, let me see, I'm gonna try to do this. Actually, just a second.
Can you go back to the previous question?
What?
Can you please go back to the previous question for a second?
Sorry, just a moment. This one?
Yes. I'm confused. Yeah, I'm confused with the line. It's saying t minus 1 whole square and the sign.
This
It means,
one?
no, the next line.
This one?
Yes.
Okay.
It means t minus 1 whole square is bigger than 0.
Right.
But you're saying it's decreasing.
Yeah, see, we always have that. I mean, the derivative has a negative sign. This is not the derivative. This is just saying that some number squared is non-negative, right?
Oh, this is not the derivative. Oh, okay.
Right. This is not the derivative yet. I'm not saying that this is equal to that. I'm just explaining that this is equal to this. I mean, this is positive. So if you multiply by a negative sign, I'm going to get something that's negative.
Oh, okay. Thank you.
Okay. So let me do then this other problem here. So actually, I'm going to erase these things here. Okay, so now in this problem, I have several examples, and I have to figure out which one of these is the derivative. Okay, so okay. So let's look at this example. So here are some functions here that are given on the top. I have to figure out which ones are the derivatives. Okay, and I have some examples. So let's start with, say, this one here. Okay, so what can we say about this function? Well, it is piecewise linear, right? So what does that mean? That means in each piece, it is a linear function. So what can we say about the slopes? The slopes are constant, right? So if you have a linear function, the line doesn't have a different slope at different places. So this thing here has a slope that's a constant in this interval here, right? So in this interval here, it's a constant, the derivative. In this interval, it's a different constant. In this interval, it's a different constant. In this interval, it's a different constant. So that means it consists of pieces. On each of those, it's a constant. And there is just one function here which looks like that, and that's this function here, right? So this one is the derivative of this. All the other ones, they don't look like piecewise constants, okay? So that means that the derivative here is this one gives you this derivative, okay? So let's look at a different example. Let's look at this example here, the first one. Okay, so this one here, looking at an example like this, the first thing we should try to do is to figure out where is this function has a slope that's has a horizontal tangent, and the points are this one, this one here, and this one here. Okay. So at those points, I have derivative has to be equal to 0, meaning that the function at the bottom has to pass through the x-axis. What are these examples? So what's left? We have this one is left, this one's left, and this one's left. Well, let's look at this one here. This one here, the blue is my curve, so that one never passes through this x-axis. So this is definitely not what I'm looking for. That's not it. How about this one here? This one here is equal to 0 only at one point here, at that point. And I need 2 points. And this one here, see, has 2 points here, where it's equal to 0. So that's the correct one. So this is wrong and this is correct. Does that make sense? So on
yeah.
the top
Wait,
line,
what's the question?
can you, yes?
What's the question? Oh, somebody's talking. Speak.
Oh, okay. So
What's the question? No, I'm just joking.
So you have to look at how many zeros there are. Like
Right. How many places where the tangent is horizontal?
horizontal.
Right. So in this picture, you look at the points where the tangent is horizontal, right?
Oh, okay.
So this example here, the tangent is horizontal. In the other picture, that means the graph of the derivative goes through the x-axis. So at the corresponding points, meaning at this point here and this point here, the graph of the derivative would have to pass through the x-axis. So that gives you, there is these 2 points through which that the function goes through the x-axis.
Yeah. What about the third graph, the W shape?
The W, no, those are the functions that are given to you. You have to match them to the corresponding things downstairs.
Oh, wait, but that also goes through 2 zeros.
Which one?
Does it? The third graph.
The third graph, yeah. So you have to pick one from the top and take the corresponding thing in the bottom.
Yeah, but graph B and graph C both go through 0.
Oh, yeah, but this one we already said number 3 corresponds to B. It's piecewise constant. The derivative is piecewise constant.
How do you know that?
This one here,
Yeah.
it's piecewise linear, right? On each line, it's a constant, so it has to look like this.
Oh, okay. All right.
Okay.
Wait. Wait.
I'm waiting.
So which one corresponds with the third one on the bottom?
The third one, okay, so the third one on the bottom. Sorry, just a moment. Right. So so we saw that. So number one,
What's the question?
which graph corresponds to the derivative? Given
Okay.
a graph, we have to figure out what's the derivative. Okay.
Okay.
So this one corresponds to that.
Because it has 2 zeros, right?
Right, because it has 2 zeros. The derivative has 2 zeros. Okay. So and then similarly, this one here has just one place where it's horizontal, where this thing is horizontal, the slope, and that means that the derivative has 1 0, and that gives you this one here. So
Oh.
this one corresponds to that, and then this one here, number 2, is corresponds to this.
Why?
Has
And
no,
yes.
graph 2 has no zeros, right?
Graph 2, yeah, it doesn't have zeros. Also, if you see here, see it's increasing here, and here it's decreasing. So that means the derivative has to be positive here in this part, has to be positive. See, it's above x-axis, and here it's negative, it's below x-axis. So that's why this one corresponds to that one.
Okay.
Okay. Okay, so I'm gonna stop here. We're out of time, so I'm gonna stop here, and so we'll continue with this section on Thursday, and I'm gonna post also both of these
Can I
sessions.
ask one more thing?
What?
Can I ask you one more thing? Oh, I just asked. What is this? What's the question?
In this question is to match the graphs and their derivatives.
Oh, okay. So wait. All right.
Okay. Okay, guys. So let's stop here. If you have questions, just let me know. And so there was a question, when is the midterm? The midterm is going to be end of this month or maybe the beginning of the next month. Okay, so I'm going to stop recording now and I'll talk to you next Thursday.
Safe up, gang.
Can you repeat that?
I said, safe up, gang.
All right. Gang shit.
Yes, we're going to have review before midterm.
Oh, another question. Where does it show? Did you let the extensions go yet? Like, did you do?
If you, I mean, depending when you did, so if you ask me for an extension, I'll grant it to you. You should see it on WebAssign, I assume.
All right, thank you. Appreciate it.
Mm-hmm.
When are you going to send the review sheet for the midterm?
A week before a midterm.
Okay, thank you.
When is the midterm?
End of the month.